In this video, we are given a couple of vectors in the form of magnitude and direction. All right, so we are given a vector, but we are given r and theta. And so we're going to sketch them using this information, and we will find out how to rewrite these in component form. So first, the sketching. Vector A has a magnitude of 6 and a direction of negative 110 degrees. Okay, so we are told that the direction is negative 110 degrees. Each one of these marks is 15 degrees from the previous mark. So because it's negative, that's why I'm going clockwise. If it were positive, I'd be going counterclockwise. So I'm just looking for where negative 110 degrees would be. So negative 110 degrees would be right about here. Now, we're also told that the magnitude is 6. Well, each one of these concentric circles is an additional 1 unit away from the origin. So if I start drawing at the origin, okay, so that is a magnitude of 1, 2, 3, 4, 5, and 6. Okay, so it should be about here. All right, so that's a sketch of vector A. Let's do the same thing for vector B. We are told vector B has a magnitude of 5.2 and the direction of 34 degrees. This is positive, so I'm going to count in the counterclockwise direction here. Remember that each one of these angles is 15 degrees from the previous angle. So 15, 30, 34 degrees is going to be right about here. So now I just need to focus on the magnitude. Okay, so that's a magnitude of 1, 2, 3, 4, 5. So 5.2 should just be a little bit beyond 5. So I'm going to put it just about here. Okay, so that would be a good sketch of vector B. All right, next we need to find the component form of each vector. Now, if we are given magnitude r and direction theta, we can use the following formula to find the component form. We will just do r cosine theta, comma r sine theta. All right, this will give us the component form of the vector. So for vector A, that's just going to be 6 cosine negative 110, comma 6 sine negative 110. And calculator. So I got negative 2.05, comma, negative 5.64. So for vector B, we'll do the same thing, r cosine theta, r sine theta. So that's going to be 5.2 cosine 34 and 5.2 sine 34. Calculator. I got 4.31, comma 2.91. For part C, we are supposed to find A plus B in component form. Well, remember, we just found the component form of A and B, so I just copied that down right here. So if we're going to add these together, we're just going to add the corresponding parts. So we can just easily do that in our calculator. So I'm getting 2.26, comma, negative 2.73. Again, I just added the x part and I added the y part, the horizontal and the vertical components. For part D, we need to find the magnitude and direction of a plus b. So remember, this is vector a plus b right here. So let's start by finding the magnitude. And we will simply use the magnitude formula, which goes like this. When you have component form, you can just do 2.26 squared plus negative 2.73 squared and take the square root of all that, and that will be the magnitude. I'm just going to put that in the calculator. I got 3.54. Now for the direction. For the direction, I like to start by drawing a diagram. So this is right 2.6 and down 2.73. It's right and down. So that means this vector is going to be in the fourth quadrant. Alright, so let's make a little triangle out of this. So it was right 2.26, so that means this is 2.26, and then it was down 2.73. That means this side is down 2.73. So we can easily find the reference angle by using the tangent function. So the tangent of the reference angle r, opposite over adjacent, so that's going to be 2.73 divided by 2.26. Notice I'm ignoring the negative sign because for the reference angle, I just want the positive version. So if I want to know the size of the reference angle, I will do the inverse tangent of 2.73 over 2.26. Alright, let's see what this is. I'm going to put this in the calculator. So the reference angle is 50.38 degrees. The direction of the vector has to be measured from the positive x-axis. So this is the angle that represents the direction. Let's call it theta. So the direction is theta. How does that relate to r? Let's see, theta was on its way to being 360 degrees, but it had to stop short by the amount of r. So in other words, theta should equal 360 minus r, minus 50.38 degrees. That's 309.62. So that's the direction. For number 11, we are being asked what is the terminal point of vector A, and here's vector A, if the initial point is 6, 9. So remember this. If the initial point is the point x1, y1, and the terminal point is the point x2, y2. Then the way that you find the component form of the vector is you do x2 minus x1, comma y2 minus y1. Okay, so in this case we are given the initial point, which is 6, 9. So we are given x1 and y1. we're being asked to find the terminal point. All right, we're being asked to find x2, comma y2. That's what we're looking for. But we are given the vector in component form. We are given the -4, comma -7. So we can make some equations out of this. We know that the way you get the -4 is by doing x2 minus x1. So let me zoom in. So we know that x2 minus x1 must equal -4. Okay, because that's how you get the x component. We know that y2 minus y1 must equal -7. Same reason. But remember, we already know what x1 and y1 is, 6 and 9. So that means x2 minus 6 must equal -4, and y2 minus 9 must equal -7. So it's just a matter of solving these two little equations. So adding 6 to both sides gives me x2 is equal to 2. Adding 9 to both sides gives me y2 is equal to, well, 2 again. And that's what we're looking for. So that means the initial point, the terminal point, which is what we're looking for, the terminal point x2, comma y2 is the point 2, comma 2. Notice that I am not using the angular brackets. All right, this notation, if I put this in brackets like this, that would mean this is a vector. This is not a vector. All right, the vector is -4, comma -7. That means starting from an initial point, it goes left 4 and down 7. And so the vector is like this. Okay, that's what this was. This is just a terminal point. Okay, the terminal point is just the point at the end. So in this example, the initial point was 6, comma 9. Okay, that's just a point. So see how the parentheses are round? Because this is a single point, not a vector. And we just found out that the terminal point is 2, comma 2. So the end point is 2, comma 2. And again, these are both just regular points, not a whole vector. It's just the beginning point and the end point. This is the end point. It's just a regular ordered pair, so use rounded parentheses. Let's do one more problem on this video. This will be a simple word problem. They get much more complex than this. But we have two bulldozers that are pushing a large pile of dirt at a construction site. One bulldozer exerts a force of 560 pounds due east. The other bulldozer pushes with a force of 770 pounds due south. Due east means just east. Due south means simply south, or like directly straight south and east. Okay, so imagine that this is my little pile of dirt that's being acted upon. Okay, that's my pile of dirt. And so one bulldozer exerts a force of 560 pounds east. So this is 560 pounds east. And the other dozer is 770 pounds south. So this is 770 pounds. We want the magnitude and direction of the resultant force. Okay, the resultant force is going to be the diagonal of this parallelogram. Okay, so the resultant force is going to be this diagonal right here. Okay, now concentrate on the following triangle. All right, concentrate on this triangle right here. All right, this is a right triangle. We have this side of the right triangle, 560. What about this side of the triangle over here? Well, that's the same as this, so that is 770. So the magnitude of the resultant is just going to be the length of this diagonal, but it's also the hypotenuse of this triangle. So the magnitude of the resultant, and I will call this vector r for resultant. So the magnitude of vector r would be written this way. It's just going to be found using the magnitude formula. So we just take the horizontal and vertical components and take the square root. So it's going to be the square root of 560 squared plus 770 squared. Okay, and that will give me the magnitude. So that just looks like degrees. Did I accidentally put degrees and not realize it? So I'm just going to put that in my calculator, and that's going to be the magnitude. I'm getting 592.10. And the units are pounds. Alright, that's the magnitude. I just got it from this formula. So that just leaves the direction. So for the direction, I'm going to forget about this whole triangle business, and instead I'm going to imagine the coordinate axes. Alright, like x and y. Okay, so it would be very easy to find the reference angle. Okay, this reference angle right here, call it R. It'd be very easy to find this. And you know what, maybe I will put this back. This is 770 over here. Okay, so I can easily find this reference angle by doing tangent. So the tangent of R is going to be opposite over adjacent, so that's 770 over 560. So the measure of angle R will be the inverse tangent of 770 over 560. Okay, so I'm just going to put that in my calculator. So that reference angle turned out to be 53.97 degrees. Now, the direction of this vector has to be measured from the positive x-axis. So this represents the direction all the way around like this. We call that angle theta. So how big is this? Well, this green angle was on its way to being 360 degrees. If it just went a little bit further, it would have been 360 degrees. It stopped short by a value of r degrees. So in other words, theta should equal 360 minus r. In other words, 360 minus 53.97. Okay, and that's going to give me the direction. So that is 306.03 degrees. Okay, magnitude and direction. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.